Welcome to the screencast for 1.5, Solving Inequalities. And so you learned before that inequalities is just an equation with a greater than or less than, so these little symbols. So I remember in when I was second grade, we talked about like the alligator. Basically, it was like the shape of an alligator mouth. Right? Oh god, that's not it. Ooh, there's the alligator. Cool. So the bite's coming to chop, whatever. I didn't tell the class that when I taught it. So adding and subtracting the same amount to each side does not change the value of the inequality, so that means we can solve by isolating the variable. Okay, so for example, if I have x equals 2, the only number I could input for x to make that true is 2. Right? If I try 1 input for x, right? So if I input x for 1 for x, I could say, okay, well 1 is equal to 2. No, that's not true. But what about if I put 3 in for x? Does 3 equal 2? No, that's not true either. So they only have one solution, unless you have something like a quadratic where that would have two solutions, two answers. And then the 1.4, when we have absolute value, those would have two solutions. But inequalities have multiple. So I could try 1, right? Is 1 greater than 2? No, it's not. What about 2? Is 2 greater than 2? No, it's not. But 3 is greater than 2. 4 is greater than 2. 100 is greater than 2, yeah? So there's lots and lots and lots of solutions. Technically, an infinite amount of solutions. Why does it keep doing that? Right, so we have an infinite amount of solutions. So we're going to plot where x is greater than 2. So first off, here is where my 2 is. And I know that 3 works, 4 works, 100 works, right? All these numbers that are bigger than 2 work, so I'm going to draw my arrow to the right. Now my question is, do I draw a closed circle or open circle? Well, 2 is not a solution, right? I tried. So 2 is not greater than 2, so I'm actually going to have an open circle. 2 is not included in my solution. So the graph shows that our solution is any number greater than 2. So remember, open dot, you're going to use an open dot for a greater than or less than, and then closed for a less than or equal than, or greater than or equal to. So here all this is saying is if you add the same number on both sides, it doesn't change the value of the inequality. If you subtract this same number from both sides, it doesn't change the value of the inequality. So basically, inequalities are solved just like regular functions, except they will have more solutions. So far that's all we know. They'll just have more solutions. Alright, so let's solve the inequalities, graph the solution set. So the first thing I'm going to do is add 3 on both sides. So I have 5x. Oh my gosh. 5x is greater than 4x plus 5. Now I'll subtract 4x from both sides. So x is greater than 5. So here's a trick. If you look at which direction the arrow is pointing, right? So if you look, it looks like it's pointing this way, right? So the arrow is pointing to the right. If you look at the inequality, but this is only true if your variable is on the left side. Your variable has to be on the left side or this won't be true. If your variable is on the left side, it will tell you which direction you'll be pointing, right? So let me find my 5. So here's my 5. So according to our little rule, it should be going to the right, so let's just double check. Is 10, let's see, is 10 greater than 5? Check. Okay, is 0 greater than 5? No, so that's not true. So 0 can't be part of my solution. It's not going to be part of the line, but 10 can be. And lastly, is 5 greater than 5? It's not, so it's going to be an open circle. Open circle. Now let's try this one. So I'm going to add 15 on both sides. All right. I'm going to get my variable by itself. I'm trying to get x by itself. So 21 plus 15 is going to be 36. Now I can divide by 4 on both sides. So I have x is less than or equal to 9. Okay, so according to our rule, it looks like the arrow is going to the left. Right, so you can see the symbol for the inequality. You can see it should be going to left. All right, so I'm at 9. And here's my 9. My arrow should be going to the left. Let's just double check. 0, right? So 0 should be one of the solutions that work because it's underneath my arrow. So 0 less than or equal to 9? It is. Cool, so we know this is right. Now we're going to ask ourselves, is this an open or a closed circle? So I'm going to test, is 9 less than or equal to 9? It's equal. So I have a closed dot because it's actually included in the solution set. So how do we know when to switch the sign? How do we know when to switch the sign? So if you are multiplying or dividing by a positive number, you don't change the sign. But if you're multiplying or dividing by a negative number, you reverse the direction of the inequality. Because basically, if you're multiplying by a negative on both sides, this will turn into a not true inequality. That's more or less the reason. I just want you to know the general rule. You need to flip that inequality whenever multiplying or dividing by a -1.